Hey guys, let's discuss a new topic on system design, designing a system, which is called design a distributed cache. So in distributed cache, we are designing this system similar to Redis or Memcached to store frequently accessed data and reduce latency on backend system. Okay, so instead of calling database again and again, the data which is getting used again and again, we will store that in a cache, okay, which is in memory, and it will take lesser time to fetch data from cache than fetching data from DB. So for example, if DB is taking, let's say, 100 millisecond, then cache will take 10 millisecond, 1 millisecond, 5 millisecond, means very nanosecond, so very less time. Okay, so let's discuss the functional requirement here. What we wanted in that system. So the first one is store key value data in cache. Okay, the cache, the format will be key and value. Then retrieve data with low latency, support cache eviction, LRU, TTL, okay, least recently used, time to leave, TTL. So I have already created one video lecture on cache in a system design core topic, okay, in a core playlist. So please go and watch that. So it will be very clear for you. Now handle cache invalidation. Okay, so you cannot keep data in cache for longer time, means for entire life, right? Because cache is expensive, and also we need to have some eviction policy also, so that we can delete data from cache. Stale data, it is old data which got changed or not in use, we remove that kind of data from cache. Now support read through, write through caching. Okay, so now there are different strategies where you can read data or update cache. So for example, read through, so cache aside, we will discuss in this video. Okay, this is strategies. And then support read through, write through caching, and then scale across multiple nodes. Okay, so it's your cache should be in multiple nodes in a distributed system. Okay, not in a single node, because of course, because of bottleneck, otherwise it will become bottleneck, single point of failure. Now optional is cache warming. So what is cache warming? So it is a technique where you preload data into cache before user requests it. So the first request is fast instead of slow. You know that let's say user has requested data and it is not there in cache. Okay, so what it will do, it will go to database, will take the data, update cache, and then send request to user. So this is for the first request, it is taking longer time. But now in second request, if user is asking the same data, it will just go to cache and return that cache. So here the first request was taking more time. Okay, so now in cache warming, we before user is asking the data, we update the cache itself. Okay, so that is the cache warming. And then distributed locking and session storage also. So session storage, you know that when user is sending request, okay, we keep the session and we store that on a server. But now here in a distributed environment, you have a multiple server, right? So it means that if you store that cache session information in one server, it means that that user is associated to one machine only, right? Then you cannot use the concept of auto scaling or the distributed environment thing, right? So instead of storing that session information in particular server, we store that in a global cache. Okay, let's say Redis cache. So in that case, your system will become stateless. Okay, so now user can connect to any server. Okay, and will process his request. So that was the session storage. So you use cache for that kind of session storage also. Otherwise it was a sticky session earlier. Now non-functional requirements. So non-functional should be ultra low latency, let's say less than 10 millisecond or ideally 1 millisecond. Okay, now high throughput, so millions of query per second your system should achieve. Okay, should process. High availability, replication and failover. High availability, how you will ensure that my system is always available, because so I will have a replication of a node, right? If one node goes down, I can switch to another node. And failover also, if one system fail, so I have another option as well, right? Scalability, horizontal scaling, and I have explained all these topics in a core system design playlist. Please go and watch that before reading this, right? So it will be that will clear your concept, and then it will be very easier to understand concept here. Now, fault tolerance and consistency, eventual and strong consistency depending on the use case. Now, estimation. So let's say if you have 10 million users, okay, and you're processing, and each user is requesting 10 requests per second, right? So how many requests you will have? 10 million into 10, right? So now one request is taking 1 KB in cache size. Okay, so this 10 million request and 10 user, how much data will it take into 1 KB, right? Means 10 million user, one user is sending 10 requests and one request is taking 1 KB data. Now 10 million, you can say, so 10 million is, you can say 10 into, means 10 to the power 6, let's say 1 into 10 to the power 6 into 10 into 1 KB means 10 to the power 3 byte, right? So here 6 and 3, how much it would be? 10 million means 10 into 10 to the power 6. Okay, so now this is 6 and 3, this one will be gigabytes, 10 to the power 9. Okay, and 10 into 10, 100. So it means that 100 GB data you would be required per second for your cache. Okay, so you can see that 100 GB request system will read. Okay, read, so this is your read heavy system, you can conclude, and needs in-memory distribution system. Okay, so now without AI, if we talk about the classic distributed cache, then in that case, what was the architecture flow? See, architecture flow, client will send request to API gateway will send request to API application server. Now application server fetch data from cache layer, okay, or Redis cluster. If it is not there, then it will go to database and then come back. So that is your fallback. If it's not there in Redis, then go to database. Very simple, right? And if we talk about those components, so client which is sending request for data, cache layer, so Redis cluster we were having there, and store frequently accessed data. Okay, now cache strategy, we are having different cache strategy. Here we will talk about two, which is cache aside and write through. So cache aside will be a lazy loading. Let's say user wanted data, it's not there in cache. If it is there in cache return that data. That condition will call cache hit. If it is not there, then it is called cache miss. Okay, now in that case, cache will go to, means it will go to, application will go to database, it will fetch data from database, will update cache, and then will return. Okay, so that is called the cache aside strategy. Now what is write through? Write through means whenever you are writing new data in a database, you are writing in cache itself, right? You are updating cache also that time only. So now fourth one is database, the component of traditional system. So the fourth one is single source of truth. Okay, all the data is there only, and used on cache miss. If there is any cache miss, it will go to database and fetch the data. Now key design concept. So here partitioning. Okay, so partitioning we achieve through consistent hashing. So I have created one video on consistent hashing where I have explained in detail what is consistent hashing, but here in brief I can explain you that you will have a hash ring where we placed the different servers. Okay, so this is your distributed environment, and then let's say this is your Redis servers. Okay, Redis server. Now you have a data in the form of key value pair. So keys will be how you will assign keys to these servers. Like if the range of the key is from the hash code, let's say, is between these and these. Okay, fall here in this area. So whatever means keys will fall in this area will be served by the next available means the next server in a clockwise direction. Okay, so this one, and then second, if it is fall from this to this, so this one will serve it. So what is the advantage of this? The advantage is that tomorrow if I need to add one more server, okay, so I don't need to remap all the keys mapping again. Okay, I need to remap only the key mapping which is for this area only. So minimum shuffling, you can say. So that is the consistent hashing and partitioning. Now replication of availability. Okay, replication for availability. So just replicate these servers here in the cache ring itself. And TTL auto expiry, you should assign TTL also auto expiry for each entry which you are adding in a cache, so that it will auto expire also, you don't face the memory issue. And eviction policy like LRU, LFU, okay, least recently used, least frequently used, so we use that kind of eviction strategy. Now let's come to with AI part. So next gen distributed caching, the example. Okay, now with AI, everything above plus intelligence layer, you will add one more layer which is called intelligence layer. Okay, so here client was same, API gateway was same, application server was same, cache layer was same, database also same. Okay, but here in cache layer, Redis cluster, you add one more layer which is ML or AI layer. And what it will do, some features we will add here, like hotkey prediction. Okay, the data which is just getting popular. Okay, for example, in your website, one celebrity commented on your website, so he knows that now this website will go viral in next 10 minutes. So he will add the information of that website in cache itself, okay, before load comes. So that is your hotkey prediction. Smart eviction, okay, you don't need to follow that LRU, LFU, it will evict it according to his probability. Okay, cache prefetching, so it will prefetch data before user asks for it. And then load prediction, it will predict the load and then auto scale your system. Okay, downsize or it will increase the number of servers in your system. So we use data pipeline, ML pipeline for that, which is data pipeline, feature store and real-time inference. So I have already explained in the earlier system design video. You can go and check there. So in see data pipeline, you will get the raw data, then data feature or feature store. So it will create a data feature from that raw data, means the data which ML required for his tuning, and then store that data in a feature store. And after that, ML model will train himself according to this data for the future use also. And on the outcome of that data from that model, it will take an action in real time, whether you need to block that system or you need to allow that user, you need to remove that entry from cache. Okay, so that is real-time inference. Now here AI enhancement, what all AI enhancement you will do here. So all the thing which I told you earlier, just in deep. So hotkey prediction, predict frequently accessed data, keep them always in cache. Smart eviction, instead of LRU, AI decide what to evict. Cache prefetching, predict next request and data, load data in advance. Load prediction, so predict traffic spikes, auto scale cache. Now without AI versus with AI. So cache hit rate, so without AI it was good, but now with AI it will be optimized, because it will prefetch the data, right? So that's why. Eviction, so LRU, LFU, and here this one will be intelligent. Scaling, this is manual, this is predictive. Latency, this is low, this is lower. Cost, this one is higher, means wastage, and this one is optimized. So you can say that a distributed cache system stores frequently accessed data in memory using a system like Redis, and to reduce database load and latency, it uses strategies like cache aside and partitioning for scalability. With AI, we can further optimize the system using hotkey prediction, intelligent eviction, and predictive scaling, improving cache hit rate and overall performance. Okay, so cache hit ratio is the most important matrix here, and use consistent hashing to distribute keys. Handle cache stampede using locking. Okay, let's say there is a cache miss and lots of requests came, so all those cache miss will go to database and query database. Okay, your database may crash, may go down. So that is called cache stampede, and you can handle that using locking. So just lock the database for particular request. Okay, other will wait. Use TTL to avoid stale data, and AI helps to improve cache efficiency and reducing cost. So that's it. Thank you.